So now I want to give a few different examples of different proof methods, basically by examples. So I'm going to do a few more proofs that illustrate different methods for different situations. So the first one is proof by cases. And in my little sort of argument diagram heuristic way, I'll write this as we want to prove some proposition P, and so we argue like so. We split it up into cases, Q1 or Q2 or Qn is a tautology, is always true. So this is essentially saying that one of these things must be true. These are our different cases. And then we just go through the cases and say that Q1 implies P, Q2 implies P, so on, for all the cases, therefore P. So this is the sort of rules of induction outline of this argument. But let's give an example, because I think that's how we'll really get an idea. So prove that the absolute value of x times y is equal to the absolute value of x times the absolute value of y. This might be a fact that you're very familiar with, but let's try and prove it rigorously. So again, where should we start? Let's start by writing down the definitions. So the absolute value of, let me use z, why not, just to make it either x or y. Absolute value of z is defined to be z, it's z or negative z, whichever one is positive, right? So it's z if z is at least 0, and it's negative z if z is less than 0. And the point, like, how does this definition help us? Well, if you don't know how to multiply absolute values, you at least know how to multiply regular numbers. These are real numbers, let's say. So on this side, we know how to multiply these things fine. So then we can split it up into cases. So x is positive and y is positive, or x is negative and y is negative, or x positive, y is negative, or y is positive and x is negative. So these are all the possible combinations, right? So let's go through the cases. X positive and y positive. So in this case, absolute value of xy, well, do we know what this is? We know what absolute value does, but we need to know if this thing is positive or negative. So let me back this up for a second and say we know the product of two positive numbers is positive, right? So then xy is positive. So absolute value of xy is just xy by this definition. And then furthermore, this, since x is positive, is the absolute value of x. And this, since y is positive, is the absolute value of y. Okay, so that case is done. Make that smaller. It's real big. All right, next case. X is negative and y is negative. Then again, we know that the product of two negative numbers is a positive number. So xy is positive. And we can write absolute value of xy is therefore xy by the definition of absolute value. And now we can use this fact about double negatives to say this is equal to the product of negative x times negative y. Because when we multiply those negatives, they will cancel out. And the reason we do that is because now this thing is the absolute value of x, right? If we look back at our definition, what is the absolute value when x is negative? It's negative x. So this is the absolute value of x, and that is the absolute value of y. So that's the next case done. So now we have two cases left, when x is positive and y is negative, or when y is positive and x is negative. And here I want to use a common maneuver that you might see, which is to say, so let's say we're in the case that one positive and one is negative. So let's say without loss of generality, x is positive and y is negative. So this is a phrase that you might see a lot, and it means what it says, although let me say a bit about that. Without loss of generality, so what that means, if you unpack it a little bit, is that here we're saying something more specific than we said here. But we're claiming that this argument is enough to get the general case. That's what we mean by without loss of generality. And essentially, it's just a thing that you can use usually when you have multiple cases that are basically the same. Because these are basically the same, right? It doesn't matter which one of x and y is positive, which one is negative. They're being treated exactly the same. And it's more convenient to just make a choice that one is positive and one is negative so that we can work with them concretely. So without loss of generality, let's assume that x is the positive one and y is the negative one. Then xy is negative, because a positive times a negative is a negative. So absolute value of xy is negative xy by this definition, which we can write as negative x times y. And again, whoops. So I said x is positive and y is negative. Let's be careful to agree with what we said. So what I want to write is x times negative y. And I want to write this because if x is the positive one, then its absolute value is that. Is this thing, right? And if y is negative, then its absolute value is this. So that is how proof by cases works. We split this up into cases. These are all the possible cases that we can get. And since it's true in each case, it is true always.